The genesis of the nuclear bomb is deeply intertwined with World War II. In 1938, physicists Otto Hahn, Fritz Strassmann, Lise Meitner, and Otto Frisch discovered that splitting a uranium atom's nucleus released tremendous energy. This revelation hinted at immense power and unprecedented destruction. The fear of Nazi Germany developing a nuclear weapon spurred Allied scientists into action. This urgency laid the foundation for the Manhattan Project. The potential of nuclear fission promised to redefine global power dynamics. The quest to build the first nuclear bomb began in earnest. The Manhattan Project aimed to develop a nuclear weapon before the Axis powers. J. Robert Oppenheimer, the scientific director, was crucial in steering this massive undertaking. Enrico Fermi's expertise in nuclear chain reactions and Richard Feynman's innovative thinking were instrumental. These figures, among many others, worked tirelessly under immense pressure and secrecy. The collaborative efforts of these scientists were unprecedented. The project faced numerous challenges, from theoretical hurdles to practical engineering problems. The secrecy surrounding the project was intense, with many unaware of the full scope of their work. Los Alamos, New Mexico, became the epicenter of atomic bomb development. The gadget, the first nuclear bomb, was a marvel of engineering. At its heart lay a plutonium core, chosen for its efficiency in sustaining a chain reaction. Designing the implosion mechanism was one of the most challenging aspects. Scientists needed to ensure the plutonium core compressed uniformly to reach critical mass. This involved conventional explosives arranged precisely around the core. Numerous experiments refined this mechanism, ensuring the bomb's success. The theoretical work was paralleled by practical experimentation. The gadget was capable of unleashing unprecedented destructive power. The Trinity Test represented the moment of truth for the Manhattan Project. The chosen site was the Jornada del Muerto Desert in New Mexico. Preparations involved constructing a steel tower to simulate an aerial detonation. Extensive instrumentation was installed to measure the explosion's effects. The anticipation leading up to the test was palpable. On July 16, 1945, at 5:29 a.m., the test was conducted. The New Mexico desert was illuminated by an intense flash of light, followed by a thunderous roar. The explosion marked the successful detonation of the world's first nuclear bomb. The explosion of the gadget was a spectacle of both beauty and terror. It was the first time humanity had unleashed such a force, a moment that would forever alter the course of history. A brilliant flash lit up the pre-dawn sky, followed by a massive fireball and a towering mushroom cloud. The sheer intensity of the light and heat was unlike anything ever seen before, a new dawn of destructive capability. Instruments recorded a blast equivalent to approximately 20 kilotons of TNT. The data collected was invaluable, providing insights into the immense power and potential of nuclear energy. The heat generated fused the desert sand into trinitite, a glassy residue that stood as a testament to the explosion's intensity. This new material was a physical reminder of the test's unprecedented power. The success of the Trinity Test was both a triumph and a harbinger of destructive power. Scientists celebrated their achievement, yet they were acutely aware of the potential consequences of their creation. J. Robert Oppenheimer famously quoted the Bhagavad Gita, "I am become death, the destroyer of worlds." His words encapsulated the profound and unsettling realization of the power they had harnessed. The aftermath of the blast was a mixture of awe and dread. The landscape was forever changed, and the scientists stood in silence, contemplating the magnitude of what they had unleashed. The scientists understood they had irrevocably changed the world. Their discussions were filled with both pride and trepidation, knowing that their work had opened a Pandora's box of possibilities and dangers. The reaction among the scientists was a complex blend of emotions. They were excited by the scientific breakthrough, yet anxious about the implications. The success of the Trinity Test validated their scientific efforts, but carried a heavy burden. The explosion was a testament to human ingenuity, but it also opened a Pandora's box of ethical questions. J. Robert Oppenheimer's reflections encapsulated the moral and ethical dilemmas faced by the scientists. He famously quoted the Bhagavad Gita saying, "Now I am become death, the destroyer of worlds." Some viewed the bomb as a necessary evil to end the war, believing it would save countless lives by bringing a swift conclusion, while others feared its long-term consequences. The environmental damage and the potential for future misuse weighed heavily on their minds. Enrico Fermi and Richard Feynman grappled with the broader implications. They debated the future of nuclear energy and its potential for both good and harm. The Trinity Test forced the scientific community to confront the ethical dimensions of technological progress. It was a moment of reckoning, a time to reflect on the responsibilities that come with such power. It highlighted the need for responsible stewardship of powerful new technologies. The lessons learned from the Trinity Test continue to resonate in today's scientific endeavors. The reactions underscored a critical lesson: with great power comes great responsibility. This principle remains a guiding light for scientists and policymakers alike. The Trinity Test marked the dawn of the nuclear age, forever altering human history. This monumental event was the culmination of years of intense research and development by some of the greatest scientific minds of the time. The explosion not only demonstrated the devastating power of nuclear weapons, but also signaled the beginning of a new era in warfare and international relations. Its legacy influenced geopolitical dynamics and shaped the modern world. The power dynamics between nations shifted dramatically as countries raced to develop their own nuclear arsenals. This newfound power also led to the establishment of various treaties and organizations aimed at preventing the proliferation of nuclear weapons and maintaining global peace. The successful detonation led to the bombings of Hiroshima and Nagasaki and the end of World War II. These bombings caused unprecedented destruction and loss of life, bringing the world face to face with the horrifying potential of nuclear warfare. The end of the war marked the beginning of a complex and often tense period in international relations. However, it also sparked a nuclear arms race and a precarious balance of power. The Cold War era was defined by the constant threat of nuclear conflict as superpowers amassed vast arsenals of nuclear weapons. This period saw numerous tests and demonstrations of nuclear capability, each one a reminder of the fragile peace maintained by the threat of mutual destruction. The implications extended beyond military and political spheres, spurring advancements in nuclear science and technology. The same principles that made nuclear weapons possible also paved the way for the development of nuclear energy, which promised a new, powerful source of electricity. Scientists and engineers worked tirelessly to harness this energy for peaceful purposes, leading to significant breakthroughs in various fields. Yet, the ethical and environmental challenges of nuclear energy persist. While nuclear power offers a low-carbon alternative to fossil fuels, it also raises concerns about radioactive waste, potential accidents, and the long-term sustainability of nuclear energy. Environmentalists and policymakers continue to debate the role of nuclear power in our energy future. The test stands as a testament to human ingenuity and the boundless potential of scientific discovery. The achievements of the scientists involved in the Manhattan Project demonstrate the incredible things that can be accomplished when knowledge, resources, and determination are combined. Their work has left an indelible mark on history. The lessons of the Trinity Test continue to resonate, urging us to harness science for the betterment of all mankind. As we move forward, it is crucial to remember the dual-edged nature of scientific progress and strive to use our knowledge and capabilities to create a safer, more prosperous world for future generations.